Hello, everyone. Hope you're doing well. Welcome back to my channel. Today we are at problem of the day 13 for the April month, and we have again a good question in front of us. It is marked as easy, but it will be easy only if you know the basic functions, which will be helpful in achieving this. Only then it will be easy. But anyway, after solving this question, at least you will have the ideas of these topics. That is the best part of it. So let's see what the question is. The question is reverse bits. So see, from last few days, I can say that in April month, in some of the days, we had some good questions regarding the bit manipulation part. If you have not done that, please do and give it a try. So that was something which I wanted to let you know. And other than that, regarding this question, it's again on bits. So what happens is, if you have given a number, let us say a number like 19 or 11, whatever it is, so that 19 or 11, whatever you're saying, is actually the decimal, right? This is a decimal representation of it. But that can also be a binary representation. Binary basically means that it's zeros and ones, right? You'll have to write it in zeros and ones. So what they're asking is, so given a number in decimal format, convert it to a binary format, reverse it, and then once you reverse it, you'll get a another binary number. That binary will have to convert it to a decimal, and then you'll have to give the value of that. And remember, one more important point is, see here, though they have not mentioned this in the question, but if you see the example, you'll get to know that they are talking about the 32-bit representation. Why I'm saying this is because, see, try to understand this fact. See here, if you, for example, the number given to us is 1, right? In decimal, number 1. What that means is, if you do the binary representation of it, you will see that in a single, rightmost place is 1, rest all of them are 0. Okay. Now, why this 32 matrices? Why this number 32 matrices? Try to understand this fact. One thing is very clear that, yeah, see, when we take a byte in C++ or in most of the languages, it's equal to 8 bits. Okay, sorry, 8 bytes, which basically means 32 bits, right? That is one point. Okay, that is fine. Other than that, see, when we reverse it, you will see like it looks like this, right? So when you reverse it and try to find the decimal value of it, so it definitely matters, right? Where is this one present, right? Because it will affect the power of one, right? For example, see, the firstmost place, that's a, yeah, this is the least significant bit, and this is the most significant bit, right? So those things will matter there. Okay, so these are some of the important parts I wanted to let you know. And see, before starting this question, please try to understand these some basic things: how to convert a number to a binary representation, and once you are given a binary representation, how to convert it to a decimal one. I hope you know them, but just for a quick recall, let me show you. For example, let us say the number 7. Okay, I am talking about the number 7. If you want to know how it is being written, so this is how it is being written. Okay, we have, these are the ones. Okay, 8421. Okay. Okay, this is the one, right? Yeah, 8421. That is fine. So, 4 plus 2, which is 6, plus 1, which is 7. So, this is the representation of it. Okay. Now, you can add some more zeros towards the left. That is fine. But still, this is what is being done. Okay. So, what it means is, the first place is 2 power 0. Its value is 2 power 0. Second place is 2 power 1. Then 2 power 2, and so on, right? So basically, you have to multiply this particular number with this place value, and you will get the final number in decimal format. Okay. The same thing is, if you do in reverse, you will get the binary representation of it. Okay, as simple as that. So a simple hint is, if you start dividing the number by 2 and collect the reminders, you will basically get the binary representation of it. Okay, as simple as that. So yeah, and that was all. And regarding this question, let us quickly see how we can solve it in Python. Okay, so let me comment this out for now. So in Python, we have two functions which I am going to talk especially for this. So first is the binary function. Okay, given any number, let us say you have a number x in decimal format. If you want to convert to a binary number, you can give the bin function. Okay, and another function is int function. Okay, int. So int what takes is that, see, it can take a number in any format. Let's say in decimal, it can take in binary, it can take in hexadecimal, or it can take in octal. Anything it can take, right? For example, let us say you are giving it a binary number and you wanted to convert to integer. What you will have to do is give the binary number in a string format and then pass the second parameter as 2. That is the basis 2. Okay, for binary the basis 2, right? So you'll have to do that and it will convert to a decimal number. So that's what we are going to do. Okay, these are the two functions which I'm going to use. First, I will show you how what the binary representation in Python looks like. Then I will tell you why all these things I'm doing. Okay, let me quickly run this code and show you first. Otherwise, see, it will make sense. Okay, just a second. Okay, I'll have to comment these things out. See, in Python, the best thing is there are so many functions. But the other point is, like, you should be, having an idea of how to use it. Okay. For example, see here, if I talk about the binary function, okay, this what is the first output, binary of x. So we are given number 33. I will put in the binary of x. So actually, this is the part of binary of x, right? But it will always print 0b. Okay. This is how the function is, printing it. Okay. It's their part. Okay. We cannot change it. So that's why I will take from the index 2 onwards. Okay. So I will take only this part. Okay. I will take only this part. Then what next I will do? See, whatever be the length of this part, what I will do is I will subtract the length of this part from 32. That is uh, let us say it has x number of bits. Okay, the highlighted part which I'm showing on the screen, let us say it has x number of bits. So I will have to add 32 minus x zeros to the left of it. Okay, as you can see here, I'm adding that many zeros here. Okay, to make it, to make the total number has 32 bases. Okay, that's what I'm doing here. So that's what is I'm doing now. Okay, so this is the first print statement that I'm taking binary of x, and I'm taking from the second index onwards. Okay, this is the actual binary part. Next one I'm taking the length of it, which I'm storing it as L. Okay, then if L is less than 32, okay, what I'm doing, I am multiplying, I'm adding zeros to the left. Okay, that's what I'm doing. How many times? 32 minus L times. Okay, and B will be there towards the right, as simple as that. So I will again printing B and showing it to you. Okay, here is how it looks. Okay, next is the reversing part. This is how we reverse it. After reversing, I'm storing it another string for your convenience. Okay, this is how it will be. After that, I'm again printing it. This is how it looks. Okay, see this part. If you take that is, see, from you will have to go from right to left now. This is how it will look. Okay, after reversing. Then I'm using the int function. Okay, I'm using the int function, passing this as the string. That is the first parameter, and in the second parameter, I'm passing the number 2, because then see, that's what I mentioned it here, right? If you pass a string, you will have to also mention what is the, base parameter of it. Okay, that's the base of it. So in this case, it's a binary, so the base is 2, and then it will give me the answer. So let me quickly, comment out the, print statements, and let us see how it works. Yeah, let me quickly compile it now. So as you can see, the answer is getting accepted now. This was for an input 33, but if you see the example test case, okay, if you see the example test case, they are taking the number 1. So let me quickly show you that also, and yeah, let me run it now. You can see the answer is coming still the same. Okay, so this was the part. Okay, and yeah, that is all. But see, remember one thing always, this might be a bit tricky in case of C plus Y. It is because uh, see, there is, when we say a 32-bit number, what happens is the one bit is reserved for the sign. Okay, so first, that is the leftmost bit is become the sign bit. Okay, it will tell me whether the number is positive or negative. Those things are also there. Okay, there is this concept as well. Okay, there is sign representation, all those things are there. Okay, two's complement and all those stuffs are still there. Okay, in Python it is very easy to, uh, alter those parameters, but in C++ it may be difficult if you are not sure. Okay, that's what it is. If you are not very used to that, then if you try to do it on the go, then definitely will face issues. That was something which I wanted to warn you about. So yeah, fine, that was all for today. This was on the easier side, provided you know these functions. But anyway, at least you now know that there is something like this existing in Python, and that's why this kind of questions become very, very easy when we start solving using Python. So yeah, fine, that was all for today. See you tomorrow. Thanks a lot.